Hey calculus, we are going to review the definition of derivative the long way, and then we're going to learn a really great shortcut. So for the first part of our note sheet, we are going to review the definition of derivative function, this big, long, messy formula to help us find the derivative function. So our first step is to set up the derivative. So the first thing we have is the limit as h approaches 0. Now we rewrite the function to x squared minus 3x plus 1. We rewrite the function, but instead of x, we plug in x plus h in both places. So that is our f of x plus h. The second part of our numerator, in parentheses, we write the function as is. So minus parentheses 2x squared minus 3x plus 1. And that is all over h. All right, so again, this right here, the first part of your numerator, that is the f of x plus h, and the second part of your numerator is right here. That is our minus f of x. All right, now the second step is all algebra. We still have the limit as h approaches 0. This too comes along for the ride because we have to do exponents first. When we square x plus h, remember we get x squared plus 2hx plus h squared. Now moving from left to right, we distribute this 3 and we get minus 3x minus 3h. Then we have a plus 1 to bring down. And now we distribute this negative. So we have negative 2x squared. Then we have plus 3x, a negative and a negative is a positive 3x. And finally, we have negative 1. That is all over h. In this example, we have one more thing to do up in this numerator. We have to distribute this 2. So we still have the limit as h approaches 0. But we distribute the 2, so that gives us 2x squared plus 4hx, finally plus 2h squared. And then we be very careful and we bring all this along. Don't forget anything and copy correctly. Minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1. All over h. Okay, so everything is expanded. The algebra is done. Now, if you do this correctly, a lot of stuff cancels out. So, it looks like I have a positive 2x squared and a negative 2x squared. It looks like I have a negative 3x and a positive 3x. And finally, it looks like I have a positive 1 and a negative 1. Okay. Now, the next thing we're going to do is we are going to write what's left. So I'm going to sneak up here. I still have the limit as h approaches 0, but I have 3 things left. I have a 4hx. I have a 2h squared. And my third thing that's left is minus 3h. And it's still all over h. I still can't do direct substitution, so now I'm going to divide each term by the denominator. Don't forget to keep bringing that limit along so you don't forget to apply the limit. So we have the limit as h approaches 0. If I divide 4hx by h, I am left with 4x. If I divide the second term, 2h squared, by h, I'm left with 2h to the first. And finally, if I divide negative 3h, that third term by h, I am left with negative 3. Now I can do direct substitution. So now I plug in h for 0. Or 0 for h. 4x plus 2 times 0 minus 3. Essentially, any term with an h is gone. So our derivative function, f prime of x, is equal to 4x minus 3. Okay, now That is a lot of work. There's got to be a shortcut, and there is. This is the greatest shortcut in math. It is called the power rule, and it only works if n is a positive integer, our exponent is a positive integer. Okay, so the first thing we're going to do is we are going to talk about notation. We've talked about f prime of x being one of the notations for derivative. Y prime is another one. The other one that you're going to see is this one right here. It looks like a fraction, dy over dx, but it's not a fraction. It is a symbol for derivative. Leibniz notation is what it's called, and it's named after the guy that invented it. But this is a symbol for derivative. It is not a fraction. And it simply stands for difference in y over difference in x, which is what the slope is, which is what the derivative is. So when you see this right here, find dy dx, this simply means find the derivative. It's just another notation for the derivative function in calculus. Okay, the power rule works for any polynomial term, and that means that you have a coefficient, that's what a is, and you have an exponent, n, and the exponent has to be a positive number. So the first step we do is we multiply the exponent by the coefficient. And the second thing we do is we subtract 1 from the exponent. So let's look at example 1 here. I'm going to make this bigger. X to the 6th. Okay, that's the same as, if we rewrite it, that's the same as 1x to the 6th, even though we don't write that 1. But the first step of the power rule is we multiply the exponent times the coefficient. So we have 6 times 1. And then we have x. And the second step is we take that exponent 6 and we subtract 1 from it. So we get 6 minus 1. Okay, so now 6 times 1 gives us 6, and then we have x, and 6 minus 1 gives us an exponent of 5. So using the power rule, the derivative of x to the 6th is 6x to the 5th. We multiply that exponent times the coefficient and put it in front, and we subtract 1 from the exponent. Remember, every time you take the derivative, the degree goes down by 1. So that's it. That's the power rule. It's much easier than that big, long, messy formula we did at the start of this. Let's look at number 2, x to the 1,000th. That's the same as 1x to the 1,000, even though we don't write it. So the first step, we multiply the exponent 1,000 by the coefficient 1, and that gives us 1,000. And then we take 1,000 and we subtract 1. 1,000 minus 1 gives us 999. Crazy. So the derivative of x to the 1,000th is 1,000x to the 999th. Number 3. Remember, 5x is the same as 5x to the first, even though we don't write the first. And 1 is a constant. A constant is the same as that constant times x to the 0. Remember, x to the 0 power is equal to 1. Anything to the 0 power is equal to 1. So now we can use the power rule. The first term, 1 times 5 gives us 5. And then if we take 1 minus 1, we get 0. So those are my two steps. The exponent times the coefficient is 5. The exponent minus 1 is 0. Now we keep going. The second term, 0 times 1 is 0. And then 0 minus 1 is negative 1. Now, this 5 comes down. We know that x to the 0 is 1. Over here, we know that 0 times anything is 0. Oops, I have a typo there. Excuse me. Let's get that done, so let's go through that again. 5 comes down. Anything to the 0 power is equal to 1. And right here, 0 times anything is 0. So this gives us 5. Okay, so the derivative of 5x is 5. The derivative of negative 1 is 0. 5 is our derivative of 5x minus 1. And remember, this is a linear function. That's a line. The slope, the derivative, is constant all along a line, so it would make sense that the derivative of a linear function is a constant function. Number 4, first step, multiply the exponent 10 times the coefficient negative 4. So 10 times negative 4 goes out front. And then we subtract 1 from the exponent. So our exponent is 10 minus 1. If we simplify that, we get negative 40 x to the 9th. Number 5, we have 3 terms. The first term, just take it a term at a time. 4 times 9 gives me 36. 4 minus 1 gives me 3. So the derivative of 9x to the 4th is 36x to the 3rd. Now we keep going. The second term, 2 times negative 3 gives me negative 6, and 2 minus 1 gives me 1. So the derivative of 3x squared is 6x to the 1st. Now we keep going. We have a constant 8. Remember, any constant is the same as that constant times x to the 0. We know that x to the 0 power is equal to 1. So using the power rule, 0 times 8 is 0. And 0 minus 1 is negative 1. Oops, I forgot the x. Excuse me. Don't ever forget the x. So again, 0 times 8 is 0. 0 minus 1 is negative 1. So if we simplify this, we have 36x to the 3rd, nothing to simplify there, minus 6x, and then this all goes to 0 right here. All right, so this right here is equal to 0. So this is my derivative. Remember, every time you take the derivative, the degree goes down by 1. So this 4th degree polynomial term is now a 3rd degree. This 2nd degree polynomial term is a 1st degree. Number 6, we take it a term at a time. First term, 5 times 8 gives me 40. 8 minus 1 gives me 7. Keep going. 5 times 2 gives me 10. 5 minus 1 gives me 4. And we know this derivative here, the derivative of any constant, is going to go to 0, plus 0. Number 7, we have a fraction. Remember, the number in front of x is a 1. So if I multiply 2/5 times 1, I get 2/5 out front. Now, to subtract 1 from this, in order to subtract fractions, you need a common denominator. We need a common denominator of 5. So what we're going to do is we're going to take 2/5, our exponent, and to subtract 1, we write it as 5/5. All right? 5/5 is equal to 1. So the 2/5 comes down, x. Remember, when we subtract fractions, we keep that common denominator, always. We only subtract the numerators. 2 minus 5 gives me a negative 3. So the derivative of x to the 2/5 is 2/5 x to the negative 3/5. The trick with fractions is when you need to subtract 1 from the exponent, you just get a common denominator. All right. Number 8, the square root of x. The power rule doesn't work for square roots. The power rule only works for polynomial terms, which means you have a coefficient and a positive exponent. So what we can do is we can rewrite the square root of x. Remember, the square root of x is the same as x to the 1/2. Remember, this is a square root, so that goes on the bottom. It is x to the 1st, so that goes on top. But now we can use the power rule. Okay, so now we have to go with our power rule. So that's 1x to the 1/2. So 1/2 times 1 is going to give us a 1/2 out front. To subtract 1 from 1/2, we take 1/2 and we subtract 2 over 2. This is the same as 1. So that gives us 1/2 x. We keep the common denominator 2. We only subtract the numerators. 1 minus 2 gives me negative 1. So the derivative of the square root of x is 1/2 x to the negative 1/2. Number 9. The power rule doesn't work for fractions, but we can rewrite this. Remember, that's the same as 1 over x to the first, even though we don't write it. And remember the rules of exponent. If we move that upstairs, the sign of the exponent changes. So 1 over x is the same as x to the negative 1. Now we can use the power rule. Oops, power rule. Okay, so that's the same as 1x to the negative 1. So the exponent negative 1 times the coefficient, negative 1 times 1 is negative 1. And then if we take our exponent negative 1 and subtract 1, we get negative 1 minus 1. So that gives us negative 1x to the negative 2, because negative 1 minus 1 is negative 2. So there is our answer. We could also rewrite it and get that exponent downstairs. So the negative stays out front, but this right here can move downstairs and become x to the positive 2. Okay, think of it like this. If I put negative 1x to the negative 2 over 1, this thing right here, because there's a negative exponent, can move downstairs, and that negative 2 becomes positive 2. So either of these, right here or right here, are acceptable answers. This one has a negative exponent. This one is rewritten with a positive exponent. Okay, finally, to review, what is the derivative of x? Well, x is the same as 1x to the first. So if we use the power rule, 1 times 1 is 1. If we subtract 1 from the exponent, 1 minus 1, we get 1x to the 0. Remember, right here, you guys, x to the 0 is equal to 1. So that gives us 1 times 1, which is 1. So right here, the derivative of x is equal to 1. That one you just want to know. The derivative of x is 1. Okay, number 11. We went through this earlier, but let's go through it again. A constant is the same as that constant times x to the 0, because we know anything to the 0 power is equal to 1. If we use the power rule, 0 times 6 is 0. 0 minus 1 is negative 1. And we know that 0 times anything is 0. So the derivative of any constant, the derivative of any number, is 0. And finally, number 12, the derivative of e to the x. The derivative of e to the x, guess what? It is the only function that is its own derivative. The derivative of e to the x is itself. All right? The derivative of e to the x is e to the x. And we will go over that more thoroughly at a later time. But thanks, calculus. That is the power rule, the best shortcut ever. All right. Catch you later.